I think we've all had that moment where we're watching an agent run in a terminal and it feels seamless. It's hitting APIs, it's reasoning logically, it's making progress. And then, for no reason at all, you hit a temporary connection drop. Or the agent hits a malformed request on the 7th step. And the whole thing just crashes. The second that process dies, you're screwed. Everything that happened in the last 10 minutes, that's gone. All that state was sitting in your local RAM, and now it's deleted. You have to start over. You have to pay for the tokens again. It's a massive headache. And it's the main reason most of the agents we see on GitHub never actually make it into a real product. You can't put something that fragile in front of a customer. As engineers, we've spent decades learning how to build reliable systems. We have databases, so we don't lose data. We have message queues, so we don't lose tasks. But when it comes to agents, we're mostly just running these naked scripts and hoping for the best. That's why I've been looking into Agentspan. When I started exploring Agentspan, I wanted to be sure that I wasn't just signing up for another framework. Like everyone else in this field, I'm tired of frameworks. I have no interest in learning yet another syntax, or writing prompts, or a proprietary way to define a tool. Now, Agentspan doesn't touch any of that. It's just a runtime. Think of it as the infrastructure underneath your code. You keep your OpenAI SDK or your LangGraph logic exactly as they are. You don't change how your agent thinks, you just change where it lives. Instead of running your agent in a volatile local process that disappears the moment something goes wrong, you're moving it to a server designed to manage and persist state. And of course, if you prefer not to juggle multiple frameworks, Agentspan provides its own native environment to build these agents from the ground up, giving you development and durability in a single unified workflow. The core of this system is actually built on Netflix's Conductor. If you've spent any time in distributed systems, you'll recognize that as the same architecture companies like Tesla and LinkedIn used to handle their massive multi-step workflows. Agentspan essentially takes that battle-tested foundation and it applies it specifically to the unpredictable nature of AI agents. I'm using a dedicated Python research agent here. The key feature isn't just the logic, but the persistence layer I've integrated, which allows the agent to save its state locally after every completed task. It's nothing fancy. If I run this normally and kill it, I'm back to zero. But watch what happens when I wrap it in Agentspan. The process will die, and my terminal will be back to the prompt. But if I pull up the dashboard, the workflow is still live on the server. That's because the moment you kick off an agent, Agentspan assigns it a persistent, unique execution ID. This ID serves as a durable reference for the agent's state. When I restart my script, the terminal simply reattaches to that existing execution context and picks up exactly where it left off. No rerunning steps, no wasted tokens, it just resumes that specific execution context and keeps moving. Now that's the difference between a demo and a system. One is a script you hope works, the other is a process that's designed to survive. The human in the loop problem. The other thing that usually breaks agents in the real world is time. If you're building a simple bot that summarizes a paragraph, it takes 5 seconds. But real agents do real work. They might need to send an email and wait for a reply. Or ask a manager for a budget approval before spending $500 on an API or a booking. If you're running a standard script, how do you handle that? You can't just keep the Python process sleeping for 3 days while you wait for a human to check their Slack notifications. It's a waste of resources. And if that process restarts, you've lost the entire context of that conversation. Usually you'd have to build a whole backend system, a database to track the pending status, a webhook listener, and a way to re-inject that state back into the agent when the human finally approves. It's a massive amount of extra baggage for something that should be simple. Now this is where the runtime concept pays off. In Agentspan, you can define a tool that requires a human signal. When the agent hits that tool, the server just pauses, saves the entire stack trace, the memory, the variables, everything, and just waits. Your local worker process can even shut down. Doesn't matter. 3 days later, when you hit approve in the dashboard or via the API, Agentspan wakes up, finds an available worker, and the agent continues from the very next line of code, as if no time had passed at all. It turns a complex out-of-sync infrastructure problem into a single line of code. For me, that's the breakthrough moment. It means I can build agents that interact with the real world, and the real world doesn't always happen in milliseconds. Observability, the flight recorder. Let's talk about debugging. When a standard script fails, you get a stack trace. When an LLM makes a weird decision, you have to dig through messy terminal logs to see the prompt. Then the completion. Then the tool output. It's like trying to solve a crime by looking at a shredded newspaper. If you're building a production system, you need an audit trail. You need to know exactly what the agent thought at 3:14 p.m. last Tuesday. Because Agentspan is built on Conductor, it treats every agent run like a formal workflow. You get a flight recorder for your agent. You can see every tool call, how long it took, what the exact payload was, and most importantly, where it failed and how it was retried. If a tool fails because of a temporary network error, Agentspan can handle the retry logic at the infrastructure level. You don't have to pepper your code with try except blocks and manual retry loops. The runtime handles the noise, so your code can just stay focused on the logic. And since it's open source, all of this, the execution data, the traces, the prompt history, stays inside your own VPC. You're not shipping sensitive system logs to a third-party cloud just to debug a crash. You own the data, and you own the environment it lives in. The infrastructure shift, scalability. Think about what this looks like in a real production topology. You've got your own Agentspan server acting as the source of truth for the agent state. Then you have your workers, the actual compute, running anywhere, whether that's on Kubernetes or just different Lambda functions, polling the server for tasks. If one worker node goes down, the server simply reassigns the tasks to the next available worker in the pool. Because the agent state is decoupled from the compute, your progress stays protected. Now as a dev, this changes your entire approach to scalability. You move past trying to scale a fragile monolithic script and start scaling a pool of workers that all contribute to these durable workflows. It's a distributed system approach to AI, which is realistically the only way we're going to get these agents to run at scale, without them being a constant maintenance nightmare. Reliability without the rewrite. I want to go back to this idea of not rewriting everything. I've seen too many tools that try to own the whole stack. They want you to use their special library, their specific prompt template, and their proprietary cloud. That's a trap. It's vendor lock-in before you've even shipped version 1.0. What I appreciate about the Agentspan approach is that it respects the tools we already chose. If you've spent weeks fine-tuning a LangGraph flow, you don't want to throw that away just to get persistence. You want to keep that logic and just give it a better place to live. When we talk about production ready, we're talking about item potency and compensation. If your agent is supposed to write a file to an S3 bucket and then update a database, and the database update fails, what happens? In a normal script, you've got a mess. You have a file in S3, but no database record. Because Agentspan is built on a real workflow engine, it understands these steps as discrete tasks. It gives you the infrastructure to handle those edge cases. To say, if step B fails, here's how we roll back to step A. It's about bringing that level of software maturity to the wild west of LLM prompt. We're moving from vibes and hoping it works to deterministic, traceable execution. The conclusion. At the end of the day, building agents is just software engineering. We've been in this honeymoon phase, where we were so amazed that the models could reason that we forgot the basics of how to build a reliable system. We stopped caring about state management. We stopped caring about failure handling. And we just crossed our fingers. But the honeymoon is over. If we want these agents to actually handle business logic, if we want them to book the venues, pay the vendors, and manage the infrastructure, they have to be durable. Agentspan is the realistic way to get there. It solves the state problem, the failure problem, and the human-in-the-loop problem without forcing you to learn a whole new paradigm. If you're tired of building fragile scripts and you're ready to build a system, go check out Agentspan docs. Spin up the server locally, wrap one of your existing agents, and try to kill the process mid-run. Once you see it resume for the first time, you'll realize why this matters. It's time to stop building demos and start building software. Thanks for watching. The links to our GitHub and Discord channels are in the description. Go break some agents and see how they survive.